Let's talk about solving differential equations with an initial value using Taylor series. For example, determine the first three non-zero terms in the Taylor polynomial approximation for the given initial value problem y prime equals 3xy squared, y of 0 equals 4. Recall from Calculus 2, second semester calculus, that the Taylor polynomial of f of x is the sum, as n goes from 0 to infinity, of the nth derivative of f at 0 times x to the n all over n factorial. Now, we saw in calculus that this doesn't have to be 0. This could actually be a. And if this is a, then this would be x minus a to the n. But usually when we have Taylor polynomials, it's not in terms of x minus a to the n. It's just in terms of x to the n. So our Taylor polynomials are going to use this formula. So in other words, we have f of 0 plus f prime of 0 x over 1 factorial plus f double prime of 0 x squared over 2 factorial, etc. In our problem, the function f of x is y. Y is a function of x. So we're going to rewrite this as y of 0 plus y prime of 0 x all over 1 factorial plus y double prime of 0 x squared over 2 factorial, etc. So all we need to do is plug in y of 0, y prime of 0, y double prime of 0, etc. And then we're good to go. Now, y of 0 we were told. Y of 0 is 4, so we're good there. For y prime of 0, we just use the fact that y prime equals 3xy squared. So let's just plug in what we know. We know that x in this case is 0, and y we were told is 4. When x is 0, y is 4. We're trying to find it at this point, 0, 4. So y prime of 0, when x is 0, y prime is going to be 3 times x, in other words, 3 times 0, times y squared, which is 4 squared, and all of that's going to be 0. To find subsequent derivatives, we take the derivative of this expression using the product rule. So by the product rule, the derivative is going to be the first, which is 3x, times the derivative of the second, that's 2y, y prime, plus the second, y squared, times the derivative of the first. Derivative of 3x with respect to x is just plain 3. And this simplifies to 6x y prime plus 3y squared. Plug in what we know, okay? So 6x, x is 0, y is 4, y prime is 0. We just saw that a moment ago. 3y squared, this is going to be 3 times 4 squared. That works out to be 48. And then we would find subsequent derivatives by calculating the derivative of the previous expression. So here's y double prime, and we take the derivative of that, and we get y triple prime. Oh my goodness. These are brutal product rule problems. So again, let's take the derivative of y double prime. It's going to be the first, which is 6x, okay, got that here, times the derivative of the second. So we need to calculate the derivative of y prime. Notice that in calculating this for the product rule, we actually need to use the product rule on this particular term because our product contains a product. So the derivative of y prime is going to be the first, which is y, times the derivative of the second, y double prime, plus the second, y prime, times the derivative of the first. Derivative of y is just going to be y prime. Okay, so that's half of the product rule. It's the first times the derivative of the second. Now we need the second times the derivative of the first. The second is y prime, and the derivative of the first is just going to be 6. And then we also need to take the derivative of 3y squared. That's going to be 6y, y prime. This all simplifies like this, so we end up with 6x y double prime plus 6x y prime squared plus 12y y prime. And we plug in what we know. X is 0, y is 4, y double prime is 48, x is 0, y prime is 0, and y is 4, y prime is 0. That all works out to be 0. So we did all of that work for nothing, literally. Just kidding. So now we want to find the derivative of y triple prime. That's going to be the fourth derivative of y. And by the time you get to the fourth derivative, you just write the little 4 in parentheses up there. So let's take the derivative of this hairy expression. I have made this term red just so we don't lose track of what we're doing. So by the product rule, it's going to be the first, 6xy, times the derivative of the second, which is y triple prime, plus the second, y double prime, times the derivative of the first. And this is what we get if we take the derivative of 6xy using product rule, 6xy prime plus 6y. The derivative of this byproduct rule is going to be the first, 6x, times the derivative of the second, that's going to be 2y prime, y double prime by the chain rule, plus the second y prime squared times the derivative of the first. Derivative of 6x is just going to be 6. And the derivative of 12y y prime by product rule is going to be the first, 12y times the derivative of the second, y double prime, plus the second y prime times the derivative of the first. That's 12y prime. So you rewrite this. Okay, so you multiply things out and you combine like terms, and this is what you end up with. So that's the fourth derivative of y with respect to x. This is brutal. So let's plug in stuff, because we don't want the fourth derivative of y. We want the fourth derivative of y at 0. So let's plug in what we know. We'll plug in x, y, y triple prime. We get this. Plug in x, y prime, y double prime at 0. That's what we end up with. X is 0. So because x is 0, I'm not even going to bother to plug in y prime and y double prime, because 18 times 0, it's just going to be 0, regardless of what these are. Let's see, 18y, y double prime, that's going to be 18 times 4. Y is 4. Y double prime of 0 is 48. And y prime squared, that's going to be 18 times 0 squared. And that all works out to be 3456, 3,456. Oh my goodness. Okay, I'm pretty good at math. I have a PhD in mathematics. But even I struggle to do this problem. I made numerous mistakes in calculating these derivatives. So, because they're so tedious. So I would encourage you to check your answer, or possibly even do the problem, using Mathematica or Wolfram Alpha. Here's how you can use Mathematica to calculate derivatives. So remember, we wanted to originally calculate the derivative of 3xy squared. That was going to be y double prime. We did that over here. That turned out to be 6x, y prime plus 3y squared. But if you just enter Mathematica, okay, d, that's the notation for derivative. This is the function that we want to differentiate. That's the variable we want to differentiate with respect to. If you enter that, Mathematica just spits out this. It spits out 3y squared, which is not the answer we wanted. Notice what went wrong. It's taking the partial derivative of this with respect to x, and that's not what we want. We want to treat y as a variable of x. So rather than calculate this, which is not what we want, type in this. So the derivative of 3x y of x squared. The y of x, with x in brackets, that makes all the difference. This is the notation for derivative. Mathematica is very picky about punctuation and capitalization, so make sure you put brackets. Functions require brackets. So we have d, you got the left bracket, 3x y of x squared. You have to put a space or a star, an asterisk, between the x and the y to represent multiplication. And you differentiate with respect to x. And your answer comes back like this, which is the answer we wanted, which is very cool. Okay, that one we could do on our own. That wasn't so bad. But then, Mathematica will do this. So you just take the derivative, you just copy and paste, take the derivative of what you just found. Again, all of this stuff that I've circled, just plug that in, and here's your output. So again, this is going to be the third derivative. Very cool. And to find the fourth derivative, yeah, you could copy and paste, but here's something that's a little easier. In Mathematica terminology, percent means previous output. So if output on line 41 was this, on the next line, the very next line, you just do d of percent comma x, and it'll spit out this fourth derivative, which is amazing. It just saves you so much time. Mathematica is so cool. If you don't have access to Mathematica, you can just use Wolfram Alpha. Wolfram Alpha is done by the same people. It's free. Just go to wolframalpha.com. So again, you enter d of 3x, got a space in there, y of x squared comma x, and it will spit this out. Wolfram Alpha is not as picky about punctuation or capitalization, so it'll cut you some slack. And this is the expanded form. It'll also tell you the expanded form, which looks like what we had. Now, if you click on the expanded form, you end up with something that looks like this, copyable plain text. Yeah, so you want this. So click on plain text, and it'll spit out this. And then when you click on this stuff here, it will copy it to your clipboard. And then you can just enter that from your clipboard into here. So you've got the D, you've got the bracket, and you press Control-V to paste it into here. Paste it from the clipboard, comma X, and it will tell you the third derivative. Okay, and then do the same thing, and you'll end up with the fourth derivative. It's very cool. Okay, so let's plug in these values. So y of 0 was 4, y prime of 0 was 0, y double prime of 0 is 48, y triple prime of 0 is 0. Still don't have 3 non-zero terms. Oh, and we're done. So this is going to be our third non-zero term. Just ignore the terms that are 0. We're not going to count those. So we end up with this. Simplify a little bit. We end up with 4 plus 24x squared plus 144x to the fourth. So those are the first 3 non-zero terms in the Taylor polynomial approximation of the solution to this initial value problem. Very cool. Okay, let's do another example. Determine the first 4 non-zero terms in the Taylor polynomial approximation for the given initial value problem, x double prime plus 4tx equals sine 3t. Notice in this problem, our function is x. X is a function of t. And if you have a second derivative, you need 2 initial values. So we have x of 0 equals 2, x prime of 0 equals 5. Taylor polynomial looks the same, except this time it's going to be x of 0 plus x prime of 0 t over 1 factorial plus blah, blah, blah. So again, t is the variable and x of t is the function. Okay, so we just need to plug in x of 0, x prime of 0, x double prime of 0, etc. So here's the original initial value problem. So what we want to do is get the highest derivative all by itself. So move the 4tx to the other side, and we have x double prime equals negative 4tx plus sine 3t. We already know x of 0 and x prime of 0. We're good to go there. We need x double prime of 0. Well, for that we just plug in. We just plug in t equals 0 and x equals 2. Plug those in. T equals 0, x equals 2. That's what we get. Sine of 3t, in other words, sine of 0. Okay, that's going to be 0 plus 0, or just 0. X triple prime, you know the drill. So this is going to be the derivative of x double prime. And again, massive, massive product rule problem. So it's going to be the first, which is negative 4t times the derivative of the second, x prime, plus the second, which is x times the derivative of the first, negative 4. And then you have to pull out the 3, because the derivative of sine 3t is going to be 3 cosine 3t. Okay, so we simplify it like this. Plug in numbers. So in this case, again, so you've got the negative 4. T is going to be 0. And x prime of 0 is going to be 5. That comes from over here. X, we know x is going to be 2. That came from over here. So we have 4 times 2. And 3 cosine 3t, that's 3 cosine 0. So we end up with 0 minus 8 plus 3, which is negative 5. X triple prime of 0 is negative 5. Oh my gosh. So again, we need to take the derivative of this in order to get the fourth derivative. So the derivative of this, by the product rule, is going to be the first, negative 4t times the derivative of the second, x double prime of t, plus the second, x prime, times the derivative of the first, negative 4. Derivative of negative 4x, that's going to be negative 4x prime. Derivative of 3 cosine 3t is going to be negative 9 sine 3t. It simplifies to this in the next line, which we can write like this, combining the 4x prime and the 4x prime. Now, let's plug in what we know. So the fourth derivative of x at 0 is going to be negative 4 times 0, because t is 0 and x double prime is 0. We saw that a moment ago. Minus 8x prime. Okay, x prime of 0 is going to be 5. Minus 9 sine 3t. Sine 3 times 0 is just going to be 0. So we end up with a 0 minus 40 minus 0. In other words, negative 40. And we're done. So this is what we wanted. X of 0 plus x prime of 0, t over 1 factorial plus blah, 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 blah. X of 0 is 2. That was something we were told earlier. X prime of 0, that's going to be 5. So we have 5t over 1 factorial. X double prime of 0 is going to be negative 5. Okay, we saw that earlier. X double prime of 0. I'm sorry, x double prime of 0 is 0. X triple prime of 0 is going to be negative 5. So we have negative 5t cubed over 3 factorial, and x, the fourth derivative of x at 0 is going to be negative 40. So this is what we end up with. And when we simplify this, we multiply things out and simplify it. We end up with 2 plus 5t minus 5/6t cubed minus 5/3 t to the fourth are the first four non-zero terms in the Taylor polynomial approximation of the solution to this initial value problem. I think that's really cool because without even really knowing how to solve a differential equation like this, we're able to come up with a decent approximation using Taylor series. Very cool.